Hi, today I want to talk a little bit about autocorrelations. And if you have some financial time series and you want to model that, and you want to put in some autocorrelation, often you look at concepts in books, and it's kind of hard to understand what the real meaning of autocorrelation is. But the reality is, it's actually really quite simple. And if you just implement it in a few lines of Python code, you will very quickly realize how easy it is and how easy it is to understand what autocorrelation actually means. So let's just do that, and let's just build a really simple autocorrelation model that we can really understand. So the first thing we need to do is we need to initialize some sort of return list, which I do here. X equals a list which only has one entry, which is 0. So the next step is we build a loop. So we just use, say, 1,000 entries. And in that loop, we append to our X. And now this is the important step. We generate a random number, in our case a normally distributed random number, and we add to it previous values of X multiplied by some factor. So what we do is we say, so now in this case our X is somehow correlated to the X from the previous value. So we now here see we multiplied it by an arbitrary factor. I give it 0.3. And you also see that we add that to our previous value. So what we expect is a positive correlation of the value at time t to the value of time t minus 1. So let's do that. And then let's just plot our result. And what we really want is, because these are our returns, we want a cumulative sum of x. And we show that. Oops. And let's see what we get. So here you can see this is a positive autocorrelation. You see, it's hard to tell, but it has actually a bit of a trending property. So I just want to show you another representation of what we just did, so to see that it's actually autocorrelated. So what we do is we plot all the values at time t versus the values at time t minus 1. So what we do is x, so that's a t minus 1, and then we go like this. So now, as you can see here, we plot the values, all the values at time t minus 1 versus the values at time t. Let's show that. And as you can see here, we don't actually see an awful lot of correlation. That's simply because perhaps we have made that factor here a little bit small. So just for the sake of showing you how that works, let me increase that factor a little bit. So let's just increase that to, say, 0.9, and then plot our autocorrelation. And you see here now it's a much better correlation. And also let's see what we get when we just plot x. And you can see here this is a very trending function. Okay, so we can clearly see that there's quite a lot of trend behavior in this. Now let's see what happens when we instead of adding our previous value, we subtract our previous value. So for that we just need to initialize again 0. Okay, and then we build our loop, and instead of the plus, you can see here we have a minus. Okay, so let's run this. Let's plot first our correlation function, and we would expect that to go negative, or to have a negative slope, and that's clearly visible here. We have a negative slope, we have a negative autocorrelation. And now let's see what we expect for our time series with the cumulative sum. And you can see here, this is a lot more what you would call mean reverting. So you can see here a lot of times it goes up and it jumps back to its similar previous value. So the overall curve still has some trends in it, but you see very clearly that this is much more mean reverting and jumps back and forth. So this is what you call a negative autocorrelation. I hope that makes sense to you. Just for the demonstration, I just want to show you what happens if we have not just one look back, or if our autocorrelation is not just correlated to the first previous value t minus 1, but also t minus 2. That's pretty simple as well. We just have to initialize 2 values first, because when we start we have to look back 2, and then here we get our loop again. See, we have I'll make that positive just because it's easier. So here we have again x minus 1, but now what we do is we add something. We say x minus 2. So it's the time at t minus 2, and let's say that time has not quite such a strong influence, so we multiply it by 0.3. And we run that again, and so what we do is we plot this, and you can see here is quite a strong upward movement. So whatever the values we've chosen are a little bit extreme, so probably we need to use something that has a bit less impact. So let's start again. So let's make that perhaps, let's do 0.2, and let's make this a little bit, or much smaller, at t minus 1. Let's do it again and plot our x, and as you can see here, we have two positive autocorrelations, and if we want to visualize those autocorrelations, we need to do this. So here we have first of all our autocorrelation at t minus 1, and because we have such a small value, we probably won't see much of a correlation, and you can see that here. However, at t minus 2, we will probably see something slightly more obvious. And it's not overly clearly visible, but you can see here that there's a slight trend in the curve. And as we increase the values, that trend will obviously be much stronger. So if you want to have more autocorrelation further back, you can just simply add more factors to it, and then just more lookbacks. And so I hope that makes the idea of autocorrelation a little bit clearer to you. If you're interested, perhaps look up in Python the autocorrelation function. So what that does is it basically gives you these factors that you can see here at each time step, -1, -2, which you call the lags, and you get then a nice chart with bars that give you all the factors for the autocorrelation. I hope you enjoyed that, and I will see you next time. Thank you.